All right, let's get right into it. If you're here, you're not looking for the high-level marketing spiel on core web vitals. No, you're in the trenches, shipping code, and you need the real engineering breakdown, the trade-offs, the gotchas, and the actual fixes that move the needle. So let's do this. Think about it. Every single day, with every commit we push, we're answering this question. Maybe shipping that new feature shaves 100 milliseconds off our hero image load time. Or adding that critical third-party script makes our UI feel just a tiny bit sluggish on a click. Or, hey, that slick component refactor, it might introduce a little flicker that wasn't there before. So, which one do you sacrifice? And look, the real answer is we don't want to sacrifice anything, right? Core Web Vitals are what give us a shared, user-centric language to stop guessing and start actually measuring these trade-offs. We're not dealing with vague complaints about a page being slow or janky anymore. Now we're talking about Largest Contentful Paint for loading, Interaction to Next Paint for interactivity, and Cumulative Layout Shift for stability. This is our vocabulary for precision engineering. And here's the absolute key. These metrics don't live in their own little bubbles. They are an interconnected system. It's like a three-body problem in physics. You push on one, and it inevitably pulls the others in ways you might not expect. Understanding this constant push and pull is everything if you want to build a truly performant experience, not just pass a single test. So let's start with LCP. On the surface, it seems simple enough. It's just measuring when the main content of your page is loaded, right? It gives the user that feeling of, okay, this page is working and useful. But what the browser actually decides is the largest content can get, well, a little weird sometimes. Now this slide explains the phantom bottleneck that drives so many teams crazy. If you've ever gotten a perfect LCP score in Lighthouse and then saw a terrible score from your real users, this is why. Field data, what your actual users experience, includes the entire server round trip. We're talking redirects, DNS lookups, the whole shebang. For LCP, your back-end performance isn't some side quest. It's part of the main event. And that high time to first byte is just the beginning, isn't it? These other patterns are probably painfully familiar. You've got render blocking resources holding the whole page hostage. And my personal favorite, the hero image that the browser only finds after it's had to parse a mountain of JavaScript. This is especially brutal in client-side rendered ops, where the page is in a mad dash to hydrate before it can even think about painting its most important element. So, the takeaway is we have to stop letting the browser guess what's important. And this right here is the solution. Instead of just waiting for the parser to stumble upon your LCP image, you scream it from the rooftops, right in the head, with a preload link and fetch priority high. You're basically tapping the browser on the shoulder and saying, hey, this thing, drop everything else, get this now. All right, let's move on to INP. So our LCP element is painted, the page looks ready, the user goes to click a button, and crickets. Nothing happens. INP, which replaced first input delay, measures the latency of all interactions on the page. It gives us a true sense of the page's overall responsiveness, not just that first click. You see, an interaction isn't just a single moment in time. It's a journey, and it has three phases. First up is input delay. That's just your user's click waiting in line because the main thread is busy doing something else. Then you've got processing duration. That's your actual event handler code running. And finally, presentation delay, the time it takes the browser to actually paint the pixels on the screen to show that something happened. Your bottleneck could be hiding in any of these three spots. Man, if this quote feels personal, you are definitely not alone. This is the classic INOP problem in modern frameworks. It's that uncanny valley of web performance. The page looks totally complete, so the user tries to interact, but, surprise, the main thread is still chugging away, hydrating all those components. The input gets stuck in a queue, the input delay goes through the roof, and your INOP score just tanks. So how do we fix it? Here's the playbook. First, start with your field data. Don't guess which interactions are slow. Know which ones are. Then you fire up DevTools and you reproduce it. In that performance panel, you're on the hunt for those big, solid yellow blocks, the ones with the angry little red triangle labeled long task. That's your enemy. The goal is to shatter that one long task into a bunch of smaller chunks, giving the browser room to breathe and actually paint stuff between all the work. Okay, finally, let's talk about the metric of user trust, Cumulative Layout Shift, or CLS. This is what happens when a user tries to click a button, but a late-loading ad shoves it out of the way at the last second. It's not just annoying, it actively erodes your user's confidence in your entire interface. And just like with LCP, there's a massive disconnect here. Lab tools just take a quick snapshot during the initial page load. But CLS is a problem for the entire life of the page.
Your field data, on the other hand, records the whole movie. It catches the cookie banner that pops in, the ad slot that resizes itself, the dynamic content injected after a user clicks something. For CLS, let me be clear, field data is non-negotiable. So how does the browser even quantify this chaos? Well, the formula is actually pretty elegant. It multiplies the impact fraction, so what percentage of the screen was affected by the shift, by the distance fraction, which is how far the unstable elements moved. Just think of it this way. A tiny element that moves a really long way can be just as disruptive as a huge element that only shifts a little bit.
And the fix, almost every single time, comes down to one single principle: reserve the space. This slide illustrates the two most common cases perfectly. For things like images and iframes, always provide explicit width and height attributes. That lets the browser block out the correct dimensions before it even downloads the content. For dynamic stuff, use CSS to create a placeholder. A simple min height can hold that space open. No more surprise movements. It's that simple. Okay, we've dissected the vitals, we know the tactics, but tactics without a strategy is just noise. In the real world, you can't optimize everything all at once. You have to make conscious, informed decisions. So let's talk strategy. Your primary vital, your hero metric, depends completely on what your application's purpose is. For an e-commerce page, that product hero image is everything, so LCP is king. For a complex SaaS dashboard, you need instant UI responsiveness, so you obsess over INP, even if it means a slightly slower initial load. And for a blog, a stable, uninterrupted reading experience is sacred, making CLS your absolute top concern. You have to know your context. And this is that system in action. This is the engineering reality we live in. You defer a bunch of JavaScript to make your LCP look great, but you risk that script parsing right when the user clicks, which then kills your INP. Or you reserve a massive placeholder to get a perfect CLS score, but guess what? That placeholder might become your LCP element, delaying the measurement of when the actual content appeared. You have to monitor and balance all three, all the time.
So how do you bake this awareness into your team's muscle memory? You start asking the right questions in every single pull request. You make performance a non-negotiable part of your definition of done. These questions force all of us to think about the real user impact of our code, not just whether the tests pass. And that leads us to the final, most crucial question. This isn't just an engineering task, it's a product decision. Every millisecond of regression is a tiny tax on your users' patience and their trust in you. So before you ship that next feature, ask yourself and your team, does the value this provides really justify that tax? When you start framing it like that, performance stops being an afterthought and becomes what it should be, everyone's responsibility.